Hey guys, what's up? How are you all? Hey guys, if I'm audible, if I'm visible to all of you guys, quickly write yo in the chat box. Hi Chandu, welcome back. Welcome Dheeraj. Hi Kiaru. Long time no see. How is everyone? कैसे हैं सब लोग? During JE preparation, JE examination discussion, a new term was invented by the student itself, Mogambians. So that's what my students are. You all are Mogambians. Welcome to this amazing session. आज हम लोग डिस्कस करने वाले हैं इलेक्ट्रोमैग्नेटिक इंडक्शन पे बेस्ड क्वेश्चंस. अनफॉर्चुनेटली आज मेंटी क्विज नहीं है. नेक्स्ट वीक ऑनवर्ड्स वी आर गोइंग टू हैव मेंटी क्विज बैक अगेन. ओके. Hi Apurv, welcome everyone to the session. I hope all of you are doing fine and all in all ready for this amazing session of EMI questions. Very nice, very nice. Yes. I do teach on Vedantu's platform as well. Obviously, I do. Right? Awesome. That's great. So, guys, all the students are ready. So, let's start quickly without wasting any further time. This is me, your Puri sir. I am a password of IIT Bombay. और जितने भी मेरे students हैं इस batch में, they all call me Mogambo on YouTube because when you will crack this examination of JEE, Mogambo खुश होगा. Okay, that's great, nice. Also, people, if you are new on the channel, then I want you people to subscribe to the channel right now. Press the bell icon so that whenever Mogambo comes live, you don't miss any of my videos. Okay, that's great. That's great. Yes, I'm there on Vedantu Pro as well. If you are interested, तो यार अगर वेदांतु के प्लेटफॉर्म पे आके पढ़ना चाहते हो तो दैट इज अ वेरी गुड कॉल ड्यूरिंग द लॉकडाउन. इफ यू आर वरीड अबाउट the social distancing and all the other norms, you can continue your JE preparation by joining Vedantu under a subscription plan, Vedantu Pro, where you are going to get live interactive sessions, unlimited test series and analysis, and study material that is always is the basic requirement of any student preparing for JE. But what makes Vedantu Pro subscription plan an even better platform and even better subscription plan or one-stop solution is that when you join Vedantu, you become a part of a long-term batch. You continue your JE or NEET preparation. Obviously, that happens with over 20 teachers constantly guiding you during your JE preparation. You have access to a huge repository of 10,000 questions. तो और कोई स्टडी मटेरियल एक्सेस करने की जरूरत ही नहीं है. You don't have to buy anything separately. No books. No, so many students keep on asking how what are the books that we have to buy and all. You don't have to buy any book. All the material is available on Vedantu. Over 10,000 plus questions. You will be tired before you solve all these questions. Okay, you have an option of learning whether in Hindi or English type of batch you want to, depending upon your communication language you prefer. Okay, also whenever required, every chapter live micro course we run for students to revise not by watching recorded lectures but by actually attending live sessions. And when the time comes, you become a part of a crash course and test series just before your examination. Okay, guys, so if you want to join for 2021 students, that means students who are right now in 12th standard, you can join depending upon your requirement. If you are new, you are not very sure about online education in general, you can first try, get to know things better. I'm sure you will then go for a longer subscription plan. If you are already a confident student can learn online, then guys, recommendation is to go for a longer subscription plan because it gives you a better fees benefit. So more fees benefits when you go for a longer subscription plan. The link is vdnt.in/ytpro, which is available in the description box. And do not forget to use this coupon code SMPRO because it will give you additional 20% discount. Okay, people, and जितने भी लोग 2021 students हैं, all you have to do here is select your standard, which is 12th standard, go for a subscription plan. When you are going to pay the fees, just make sure that you're using the coupon code SMPRO and then click on enroll now. Okay, that's good. Nice. So guys, let's begin our electromagnetic induction quiz. There will be a lot of questions for you guys to solve today, right? So are you all ready? If you all are ready, then just write yo in the chat box quickly so that we can go forward from here. Yes, obviously, future chapters, everything. Okay. Are you all ready? If you are, then just write yo in the chat box quickly and spread the word that the quiz is starting. क्विकली अपने दोस्तों को बता दो व्हाट्सएप पे सोशल मीडिया प्लेटफॉर्म्स पे लेट देम नो दैट द ईएमआई क्विज इज स्टार्टिंग ऑन Vedantu's J channel. Yes, Suvarna, I'll be back with Menti quiz next week. Don't worry. Okay. Yes, so everyone is ready. That's good. So, guys, first question on the screen for all of you guys to try. Question says that a coil having an area A naught is placed in a magnetic field which changes from B naught to 4B naught in a time interval of T. So, the EMF induced in the coil will be how much? As you can see, all the options are positive. Okay. तो EMF का जो फॉर्मूला है उसे सिर्फ d phi by dt लिख लेते हैं and that is, as you can see, area is not changing, going to be delta b by delta t or db by dt ही लिख देता हूँ for everyone to try. Okay, so what is the answer that you are getting? Okay, let's try. So EMF comes out to be area, that is A naught, change in magnetic field is 4B naught minus B naught. This is happening in a time of t. So what I get is A naught 3B naught by t. That means answer comes out to be 3A naught B naught by t. That's the EMF which will be produced, and looks like the correct answer is option A. Who all got this answer right? कितने लोग आंसर करेक्ट आ गया है? I can see Muhammad Abdullah got this right. Surinder, Antara, no Chandu. Correct answer is option A. Yes, Tech 1000, how are you? Good to see you, man. That's good. That's good. No problem, Roshan. Try to understand by following the instructions here. Hi, Mahima. Hi, Tech 1000. Very good. आज मेंटी नहीं है सुरेंद्र, नेक्स्ट वीक मेंटी करेंगे, आई प्रॉमिस. थैंक यू, आई एम गुड टेक 1000, थैंक यू फॉर आस्किंग. चलो आगे जाते हैं. लेट्स गो टू द नेक्स्ट क्वेश्चन. नाउ दिस वन सेज अ कॉइल हैज 500 स्क्वायर लूप्स. नंबर ऑफ टर्न्स बताए हुए हैं. ईच हैज साइड लेंथ ऑफ 10 सेंटीमीटर placed normal to the magnetic field which increases at a rate of 1 Tesla per second. So find out the induced EMF now. So induced EMF is going to be delta phi by delta t, and here again magnetic field is changing, the number of turns are not changing, area is not changing, but your magnetic field is changing. The number of turns are 500, area for a 10 centimeter square will be 10 square, right? But then every length that we are talking about is given in centimeters, so when I'm going to put that value, it's going to be 10 into 10 into 10 to the power minus 4. That's your area. And magnetic field is 1 Tesla per second. This is how it is changing. So this is 5 into 10 to the power 4 into 10 to the power minus 4. These are all 10 to the power 4 and minus 4. Cancels. Answer comes out to be 5 volts. That means correct answer is very simply option D. Okay, that's great. Soham, uneven surface के लिए कोई formula नहीं है. In that case, you will have to differentiate, find out the value. Okay. Yes, Amaze, you are right. Chalo, moving on. The next question, guys, quickly try to solve and spread the word. Tell your friends the quiz has started. Next one, an EMF of 5 volt is produced by a self inductance when the current changes at a steady rate from 3 ampere to 2 amperes in 1 milliseconds. Okay, so the value of self inductance will be how much? We know that E, which is equal to delta phi by delta t or d phi by dt, and phi is equal to Li. When you put it here, it comes out to be L di by dt, right, guys? So EMF is given to us as 5 volts, L is unknown, current is changing between 3 and 2 as the value, and this is happening in 1 milliseconds, right, people? So when we look at this, this is 5 into 10 to the power minus 3 equal to L into 1. So L comes out to be 5 into 10 to the power minus 3 Henry, or you can say it is 5 millihenry. Are you getting the answer as option D, everyone? Very nice, very nice. Nayan, Lata, Nehil, Debroy. Very good, guys. Very good. Keep it up. No problem, Tech 1000. That's great. That's great. Very good. Chalo, guys. Moving on to the next one. This one says a conducting circular loop is in perpendicular magnetic field of induction 10 to the power minus 2 Tesla. If the radius of the loop starts shrinking at a uniform rate of 1 millimeter per second, then the EMF induced in the loop will be how much? Now, somebody was asking about variation here. So, what will happen in this case? So we have a circular loop and we are interested in finding EMF where magnetic field is not changing and area is changing. So it will be B into dA by dt. So we have to find out the induced EMF and all the options are positive. So we are not concerned about the negative sign here by the Lenz law. Okay. So area for a circular loop, as you all know, is pi r square. So when you put it here, it will be B and d by dt of pi r square. So when you differentiate it, B remains as it is, pi comes out, and r square differentiation is 2r, and we are left with dr by dt. So we have 2 pi rb dr by dt. 2 pi, the radius is given to be 10 centimeters. That means it is 1 by 10th of a meter. Magnetic field is 10 to the power minus 2, and dr by dt is 1 millimeters per second, which is 10 to the power minus 3. So when we simplify this, it comes out to be 2 pi into 10 to the power minus 6 volts, or it is simply 2 pi microvolts. Are you getting it, everyone? Answer is option D. What happened, Giridhar? Very good, everyone. Very nice, very nice. Keep it up, everyone. Chalo, let's move on to the next one. This question says that the current in a coil is changed from 5 to 10 amperes in this much time and 50 millivolts is induced. So what will be the coefficient of mutual induction? That means EMF will be equal to m delta I by delta t. EMF का वैल्यू दिया है 50 into 10 to the power minus 3. M हमें पता लगाना है. Current is changing by 5 and this is happening in 10 to the power minus 2 seconds. So 5 cancels it 10 times. M comes out to be 10 into 10 to the power minus 3 into 10 to the power minus 2, or simply 10 into 10 to the power minus 5 Henry, because options are in micro Henry. So 100 into 10 to the power minus 6 Henry, or simply 100 micro Henry is the answer that I'm getting, which is option A. Very good. Tech 1000, Dave Roy, Andu. Correct answer is option A. Very good. Very good. Nayan. Keep it up, guys. Keep it up. Very well. Very well. Awesome. Very good. Snehil. Abhishek. Interesting. Very nice. Durgesh and Amar. Keep it up, guys. Let's go to the next question quickly. Next question is energy stored in a coil of self-inductance 40 millihenry carrying a current of 2 amperes will be how much? I'm giving you people to try this. Take 2 minutes and solve this. Formula is there in front of you. Half Li square. बहुत ही simple सा formula है. Yes, interesting knowledge. What's your name? Hi, gaming Harish. Welcome to the channel. If you are new, so guys, what's the answer that you guys are getting? क्या answer आ रहा है? Quickly, the answers. Okay, Abdullah is getting answer as C. Interesting knowledge also. Bunny is also getting the same answer. Very good. These are the first three people: Dave Roy, Abdullah, and interesting knowledge. Very good, guys. Okay, Harish. So guys, answer is half into L, that is 40 into 10 to the power minus 3 Henry. Current is 2. तो अगर 2 अच्छा उसका स्क्वायर करना पड़ेगा. So when I cancel that square, I get 80 into 10 to the power minus 3, or it is 8 into 10 to the power minus 2, or simply 0.08 joules. Correct answer is option C. Very good gaming, Adish. Good to know that. So, guys, yes, very good. Congratulations, those who got this right. Moving quickly to the next one, which is a challenging one. Here we are converting a square loop into a circle whose radius is not known. What is given to us, that square loop has a side A, and here the radius R is not known. So obviously perimeter will be same. So here the perimeter is 4A and here it is 2 pi R. So the radius of the square loop in which you are converting it will be 2A by pi. Right guys, that's the radius. ये radius हो जाएगा. Question में हमसे पूछा है, what it is asking us is that if there is a magnetic field which is perpendicular to the plane, and if this change occurs in t seconds, the area is changed from square to circle, then what will be the induced EMF here? Very good. So induced EMF is going to be B into delta A by delta T. So area finally is going to become pi r square. Earlier it was a square. This is happening in time t. I have B by T. Pi r square means 4a square by pi square minus a square. Right guys, r ka value is what I'm putting here. So you can see one pi is getting cancelled. So this is ba square by t, and I have 4 by pi minus 1. That's the EMF induced that we are getting. As the correct answer is option C. Yes, Chandu, you are right there. Very good. Those who are able to solve this question, that's a good question to crack. Very good. Nayan, Bunny, Tech 1000, Abdullah, Debroy. Debroy, correct answer is option C. Very good, Durgesh. Durgesh Nandini. Okay. Cool people. Now this one. We have a rod which is rotating with an angular velocity omega here. So if you use the right hand palm rule, you will realize that this end is going to the upward direction, this is going to the downward direction here. So O will have positive polarity and C will have negative polarity, and similarly A will have negative polarity. So this length in the rod is given as L and this one is given as 3L. So you can see that this is your higher potential point and C and A are the lower potential point. Question is asking us to find out which of the options are correct. So if we look at V in general for a rod, single rod, then it is half B omega L square for a single rod which is rotating like this, right? Now in this case, if we look at say VO minus VA, that will be half B omega L square. But here what is written is VA minus VO, that's why it is not correct. So if we look at VO minus VC, it will be half B omega and length is 3L, square that value. It comes out to be 9 by 2 B omega L square, VO minus VC. The correct answer comes out to be option B. Okay. Thank you, Chandu. Okay, that's good. Tech 1000. Hi, Ayushi. Guys, so correct answer comes out to be option B. Yes, yes, yes. Chalo, moving on to the next question. In this one, we have a square loop which is placed near a wire which is carrying a current I, and this loop has left end at a distance A and right end at a distance 2A from the wire, and this loop is moving with a velocity v to the right hand side, and the question is asking us to calculate the induced EMF or motional EMF, if you remember. So motional EMF will be delta B here into V into L. BLV is what we are going to solve. This is going to be B1 minus B2 into L into V, and the L is nothing but the length of the loop here. So B1 is going to be mu naught I upon 2A by 2 pi A, because it is the straight wire, and B2 over here is going to be mu naught I upon 2 pi into 2A, so that will be 4 pi A to L into V. If I take mu naught I upon 2 pi A outside, I'm left with 1 minus half L into V here, and L becomes A. A gets cancelled. this will be half, so it is mu naught IV by 4 pi is the answer that I'm getting here. Get this right? This is nothing but your L. So that's why correct answer looks like is option A here. Okay. What happened, Mohammed? Here the magnetic field will be B1. Here it will be B2. So there is a difference in the magnetic field, and this loop is moving to the right hand side. So magnetic field is going to change because of that motion. You will have an EMF which is BLV, but B on the left hand of the loop and B on the right hand of the loop are different. That's why the difference of that magnetic field is what we are taking into account. So at distance A, magnetic field is mu naught I upon 2 pi r, so that is 2 pi A. And at a distance 2A, it will be mu naught I upon 2 pi into 2A. Okay, I'll write that separately for you to understand. B1 is mu naught I upon 2 pi A, and B2 is mu naught I upon 2 pi into 2A. वो value हो जाएगा mu naught I upon 4 pi A. That's not a semi-infinitely long wire नहीं है. It's an infinitely long wire, because of which we are writing B1 and B2. Okay. The answer that we get is option A. Okay. Arun will have Menti quiz next week, not this week. Okay. Okay. Now this one, this says that we have an LR series circuit which was charged, and now you are short circuiting it by connecting A and B directly. Question is asking you the current in the circuit 1 millisecond after the short circuiting. So what was the initial value of the current? Maximum value was nothing but E by R. E value in the question is given to you as 100 volt. Resistance is given as 100. So it is 1 ampere current that you have. For discharging, I will be equal to the discharging equation which we studied on Saturday. I will be equal to I naught e to the power minus RT by L. So I will be equal to I naught e to the power minus R value, that is 100, after a time that is 1 millisecond, that means 10 to the power minus 3, and L value is 100 millihenry, so that is 100 into 10 to the power minus 3, and that gives you I naught e to the power minus 1, or simply I naught by E. What is the value of I naught? Just put that here, we get the answer as 1 by E. So the current in the circuit after a time of 1 millisecond will be 1 by E amperes. Getting it, everyone? We get the answer as option A. Very nice. That's good, guys. That's good. Okay. So this brings us to the end of the quiz for the day today. Okay. And if you are new on the channel, all the students who are new, you want to know how can you cover up the topic that you have missed, one way is to go to the channel playlist and look for the channel playlist GFlow 2021, that is for 12 standard students. और अगर 11 standard students हैं तो GFlow 2022 is the series for you guys. And another way is to be on Vedantu its own platform, और वहाँ पे you can attend all the classes live. Okay, if you don't want to watch recorded sessions on YouTube, you can come and attend all the sessions live by micro courses. Okay, yes, none of them are recorded, all of them are live courses by joining Vedantu Pro, and this is how the Wave platform looks like. All you have to do, guys, follow the link which is available in the description box and use this coupon code SMPRO and choose the subscription plan that you want to go for, 1 month, 3 month, or 6 month. Get an additional 20% discount for the same. Okay. Also, if you are a student who is thinking of taking a drop for JEE 2021 January month, that is also a good news that we have a new exclusive batch which has started on 21st of September. All you have to do is again follow the link, use this coupon code, and just enroll now. Okay, so all the problems been taken care of. And if you are new on Vedantu and haven't joined the Telegram channel, which is totally free of cost, okay, you can join the Telegram channel of Vedantu to get study material, also the assignment solutions, and the daily updates of whatever is happening on this channel. Okay, so for that, okay, what will be the next topic? We'll be talking about alternating current next time. Okay, 2021 students. Cool. So guys, this brings us to the end of the session. Agar session में मजा आया तो definitely press the like button, share with your friends, and subscribe to the channel right now and press the bell icon so that whenever Mogambo comes live, you get the notification. Okay, guys. So, with a promise that now I'll see you guys more frequently, I'm back again with all the problems being taken care of. I know you guys have been asking questions, you guys were missing me. I was also missing you all, and I'm back here again. In fact, all the students, stay tuned. We are going to have fun sessions as well. Okay, so I'll see you very soon. Till then, take care. Bye bye, guys. Good night.